Hello guys, welcome back. So in this lecture, let's quickly implement the remove method in the doubly linked list. We have seen how insert method works. So we are going to take a reference of the insert method and we are going to implement something similar to that one, but in opposite direction. So in insert, we were inserting a new node and we were making the new connections. In this one, we are going to break the connections and we are going to connect the existing nodes. Okay, that is all we are going to do in this lecture. So before jumping into the implementation, let's just quickly understand how remove works in the doubly linked list. Okay, so as you can see, we have a doubly linked list here on the screen. Okay, so let's say we want to remove the node which is at position 1 right now, which is in the yellow color. Okay, so I took the reference from the previous I think previous slide only. Okay, I'm just gonna reverse play it. Okay, so here as you can see, this is the one which I want to remove. Okay, so this is the linked list right now. So A, X, B, C, D, right? So far so good. So if you want to remove it, what you have to do first, you have to break these two connections from X to B, and then these two connections from A to X, and then you have to connect A to B, right? That means A dot next you have to set B, and B dot previous you have to set A. Okay, and then A dot next, A dot previous you have to set as null. Then only this node will become independent. Okay, after playing the slide you will get to know how it is gonna work exactly. Okay, so let's say we want to remove this node, then what we have to do, we simply have to break this connection like X dot next, we have to remove, we will make it as null. Okay, earlier it was B. Okay, now B dot previous, earlier it was stored as X, so we are going to remove that connection as well. Okay, and then B dot previous we are going to make A, right? So earlier it was B dot previous was X, right? Now we are going to point B dot previous as A. Okay, so this is going to be our new previous node, right? Same thing we are going to do with the connection between A and X. Okay, so we are going to remove the X dot previous, which is currently A, so we have broken that connection, and then A dot next right now is X, right? So we are going to point A dot next to B. Okay, so something like this. So this way the X is an independent node right now, which is not connected to the linked list at all. Okay, and A and B are connected to each other. Okay, so that means we have simply removed a node from the linked list, and we have attached the previous and the next node of the removed node to each other. Okay, that is all we have to do in the implementation. Okay, so let's quickly jump into the implementation. Okay, so here as you can see, I have this code ready for the insert. Okay, so let's quickly implement the remove method. Okay, so in remove we need the index. Let's quickly pass it. We will handle the edge case, so I'll copy it from here. So if the index is smaller than 0 or it is greater than length, we simply are going to return null. Null or undefined, it's up to you guys. It's your personal preference. Okay, now the next thing I'll copy from here. Okay, so if the index is 0, okay, so if the index is 0, then instead of adding a new node, we have to remove a node, right? So for that we already have a method which is shift. Okay, so what it will do, it will simply remove the node from the beginning. Okay, so if the index is 0, that means we have to remove the node from the beginning. We are going to use shift method. Same thing here. If it is a last node, that means if it is the length minus 1 node, okay, if you want to remove it, then in that case, see what push does is it pushes the node at the very end, right? And pop removes the node from the end, right? So what we are going to do, we are simply, okay, instead of this value we have to pass the index, right? Or I think in pop we don't even need to pass any index. Yeah, and in shift as well, I think we don't need to pass any index. Yeah, okay, so we just have to simply call these methods, and these methods are going to return the removed node. Okay, so far so good, right? So if we have to remove the node from the beginning, we are going to use the shift method. If we have to remove the node from the end, we are going to use the pop method. Okay, now what we have to do is, if we have to remove the node from the middle, right? See, in singly linked list, I wanted to cover one more thing, guys. I actually just now I realized that I missed it. Okay, so in singly linked list, how we used to remove the node is, let's say our node is at the very end, like let's say last second node, let's say C node. Okay, so in singly linked list, since it is one directional, so we have to go from the A all the way up till the C node, A, X, B, C, right? Because we cannot access the node from the last node because there is no previous connection in the singly linked list. But we can take leverage of this thing in the doubly linked list since it is both directional. Okay, so what we can do, if it is last second node, okay, then we can start from the tail itself. Instead of going from all the way, from the head all the way till that particular node, we can start from the tail and we can reach that node and we can disconnect it. Okay, so that is what we do when we remove a node. Okay, and thankfully we already have implemented a method which will do the job for us, so which is this get method. Okay, now what I'm going to do is I'm simply going to use this one. Okay, so current node, here I'm going to pass the index to fetch the node at that particular index. Okay, and then I will pick the previous node and next node of the current node. Previous node, oh, node, so this one is going to be current node dot previous. Okay, and next node is going to be current node dot next. Okay, so far so good. I don't think like this that there is something which is complicated, right? So next. Okay, so now we have stored current node which we are getting from the index with the help of this get method. Okay, and then we are storing the previous node of that current node, we are storing the next node of that current node. Okay, now in order to remove the node, in order to remove this node, what we have to do is we simply have to set previous node dot next to this next node. Okay, let's do that first. Previous node dot next, we are going to store the next node. Okay, and same way we have to store next node dot previous. Okay, this one we have to store, I'm doing a lot of mistakes, I don't know why. Okay, so this way we have built the connection between this node and this node with the help of slide. We have built a, or let me quickly show you. Okay, so we have built a connection between this node and this node. Okay, so A to B we have built the connection. Now we have to remove the connection from A to X and B to X. Okay, so for that what simply I will do is I will simply set current node dot next to null and current node dot previous to null. Okay, and then this dot length minus minus and then return the removed node. Okay, or let's name it as remove node itself, right? Okay, so yeah, now we have to return the removed node. Okay, so this is all we have to do in order to implement the remove method in the doubly linked list. Okay, it's not that much complicated since we have already implemented all these things, so we don't have to do much work in it, right? And if you want to learn about these get method, shift method, pop method, okay, so you can watch my previous videos. There I've explained briefly how these works, how we have implemented it step by step. Okay, so make sure to go and watch it out. Okay, so yeah, let's quickly test it. So we already have a doubly linked list of 4 nodes, 0 1 2 3. So let's quickly see if it works. Okay, so DLL dot remove. Let's remove from the beginning, or let's remove the third node 0 1 2. Okay, 2. So this node got removed, and as you can notice, the next and previous for this node is null. Okay, that means this node is simply independent of the linked list. It does not have any connections in the linked list. Okay, so this is what this node is all about. Okay, now since we have removed the node, we have to check whether this connection is established or not. That means hello and dude are connected to each other or not, since we have removed bro. Okay, so DLL, let's quickly see. So we have head, we have tail. Okay, so head dot next, we have to see head dot next is hello. So head is hi, head dot next is hello. Hello dot next, let's see. So hello dot next is dude. That means hello dot next is this one. So this one got removed successfully. Okay. So now let's see dude dot previous. Right. So if we see, this is dude node, right? Which is this node. So dude dot previous is hello, right? Which is basically this node. That means this node is pointing to this node and this node is pointing to this node. So there's no relation between this node with these two nodes, right? So we have successfully removed the node from the middle of the linked list. Okay, now let's quickly see if we can remove the node from the what you can say, dll dot remove at position 0. Let's see. Okay, so it should remove the high node. Okay, so high got removed. If we check DLL again, length is decreased. Okay, so now the new head is hello, right? As you can see here. Okay, and the last node is dude. Okay, so let's quickly see if we can remove what was this dude node, last node, right? So this remove, and I think the length is 2, so let's pass 2. It will be, I think, 0 1. Let's pass 2. Let's see what happens. Okay, uncaught cannot read properties of null reading previous. Okay, so there is something which I think which got broke, right? If it is greater than equals to length, then we have to return null. Okay, so this was the thing. Now let's quickly see. Now since we have refreshed it, so the length of the linked list will be 0 1 0 1 2 3 3, right? So let's see if we can remove the third node. Okay, so dude got removed. Let's try to remove the third node again. We are getting null here. That means there is no node at position 3. Okay, so let's pass 5. We are getting null. So this was a thing. So if the index is greater than or equals to this dot length, we have to return null. If it is similar to length also, then as you can see, it failed, right? Because our linked list is 0 based. It is 0 1 2 3 indexed, right? But since I've passed 4 index, or in the previous case I've passed 2 index, 3 index. Okay, so there was no node at position 3 and that case was not handled, so that's why it failed, right? So that is what I have did. I simply have covered that condition as well. Okay, so yeah, so now as you can see, we can successfully remove the node from the beginning, we can remove from node from the end, we can remove from node from the middle, right? So yeah, with this we are done with the doubly linked list remove method, and with this we are done with the implementation of the doubly linked list itself. We have covered almost all the methods which are required for our doubly linked list. Okay, so now from the next video onwards, we are going to jump into the new data structures, or we can say stacks and queue more precisely. So yeah, this is it for today's video. Can't wait to see you in the next videos, because next videos are going to be a little bit more interesting. So stay tuned. So see you there.